of the application of thin film interference is anti-reflection films. They are anti-reflection films or non-reflecting films. So this is non-reflecting films. Reflecting films. So basically these films are required where you want that all the light incident it should be transmitted. ठीक है? A very small or no reflection should take place. So here what we want that there should be no reflection, all the light should be transmitted. So what is the objective of this? No reflection should take place ideally. No reflection should take place. Should take place. All the light should be transferred. ठीक है ना और transmitted. All the light should be transmitted through the film. This is our objective. So where you are going to use this type of film, for example, on the lens of telescope, on the outer surface of the on the outer surface of the lens of telescope lens. ठीक है here this lens is receiving light from very distinct stars, so you don't want any of the light that should be reflected back. You want that most of the light should transmit through the lens. So here you can use this type of non-reflecting films. You can use. So what is important here? Here there will be a substrate. You can say this is a glass substrate. ठीक है ना? This is a glass substrate here. On this glass substrate, it may be lens or it may be any another object on which we want to do this coating. So this is glass here. On this glass, we want a thin film coating. So on this, there will be a film. So this is anti-reflection film. What is this? This is anti-reflection film. Anti-reflection film. And on this side, this is air. This is air beta. And first medium is air, second is film, and third is glass. And what we do, ठीक है, here these anti-reflection films, they are always designed for the normal incidence. So one more thing you have to remember that these non-reflecting films, non-reflecting films are designed for normal incidence. For normal incidence. What is the meaning of normal incidence? Suppose this is a surface or interface on which light is incident. So here for normal incidence means angle of incidence will be 0. So try to understand how you define angle of incidence. Suppose some light is incident like this. So at the point of incidence here, you are going to draw a normal on the interface. And this angle, you call this angle as angle of incidence. What you call? You call it as angle of incidence. Now, when this angle is 0, then you are going to call it normal incidence. It means when light is falling normally on this, okay, it will transmit it, a part of it will be transmitted, a part of it will be reflected. So in this case, this is called as normal incidence. So what we want that only this transmission part should be there, this reflected part should be 0, or if it is having, or it should be minimized. You can say either it is 0 or it should be minimized. So that type of film we want. So for this purpose, here this will be designed for normal incidence, but I'm showing you to explain you. I'm considering it as at some angle. It is incident at some angle, suppose. Later on, you can change this angle of incidence to 0. So here, this is incident light. That is, okay, this is incident light. This is the planar wavefront that is falling like this. Now, what will happen? Here, draw a normal. A part of it will be reflected here. Okay, so this is R1. We are all aware about it. Now, this first, okay, now try to understand here. Here, because this first reflection, this is air, this is anti-reflection film. So you can say this is rarer and this is denser. This is denser. So at this interface, first medium is rarer, second is denser. So basically this light is reflected back from the denser medium. So this will be pi. This will be pi. This is the first part. This is the first part. Now, this light will strike here. This light is going to strike. This will bend towards the normal and it will strike at the second interface, this interface. This is angle of incidence. You call it as R. You call it as R. Now, try to understand in case of whenever you are designing non-reflecting films. So if refractive index of air, you write it as mu A, that is equal to 1. You are writing this is mu F, refractive index of the film material, and here this is mu G. What you have to take care of, that these refractive indices, they should be in the increasing order. So for anti-reflection films, what is needed? That mu A should be less than mu F and mu F should be less than mu G. So this type of this type of sequence we are going to choose for the refractive indices. So the refractive index of the film should be in between air and mu G. So this should be like this. So it will be sandwiched between these two mediums and its refractive index should be greater than the refractive index of first medium but less than the refractive index of the third medium. Okay. So here what I am saying here, this mu f is less than, sorry, this mu f is less than mu g. This is g beta. So here this is g. This is g. Mu g here. So now if mu g is greater than mu f, then you can say this is rarer medium. Here you will say this is rarer medium and this is denser medium. Here. Now this light will reflect back from here. So this reflection will take place from here. So it will be reflected back like this. So where this second reflection is taking place, try to understand. Where this second reflection is taking place, this is taking place again at the denser medium. So this was the first reflection which was taking place at the denser medium. Extra phase of pi was there. But similarly here, the second medium is denser, first medium in which light is traveling, that is rarer. So here the second reflection, that is also taking place at the denser medium. So an extra phase of pi will be introduced in this reflected wave, and this reflected wave, it will transmit into the air like this, and this will be R2. So here this R1 and R2 both are carrying extra phase of pi. Both are carrying extra phase of pi. Okay? And what will be the path difference now between R1 and R2? Now path difference. So extra path that is carried by R1 is lambda by 2. Extra path that is carried by R2, that is lambda by 2. So both are carrying extra path of lambda by 2. So when you will calculate path difference between R1 and R2, this lambda by 2, it will cancel out and net path difference, ठीक है, delta, this will be how much? This will be 2 times mu f, ठीक है, 2 mu f t and into cos r. That lambda by 2 is gone because here two reflections are taking place and both the reflections are taking place at denser medium. So both times this extra phase of pi will be introduced like this. For normal incidence, for normal incidence, angle I will be 0, and from Snell's law, angle R will also be 0. So this will be cos 0 will be 1. So part difference here, part difference will be 2 mu F into T. T is the thickness of the film. So what is T? T is this thickness of the film, anti-reflection film. So one very important aspect is that refractive index should be in the increasing order. Second, we have find out the part difference between R1 and R2. Now what you want here? You want no light should be reflected back. It is designed for a particular wavelength. Try to understand this this non-reflecting film. This is designed for a particular wavelength. So I can write another point here. Non-reflecting films are designed for a particular wavelength. For a particular wavelength, and you don't want any reflection. ठीक है, what is your objective? You don't want any reflection. So कोई reflection नहीं होना चाहिए. This is your objective. So what should happen for this wavelength in the reflected light? So here, when these two lights, when these these two wavefronts R1 and R2, when they are superposing, they are interfering, they should form a minimum. So in between R1 and R2, for that particular wavelength, ठीक है, minima will should be formed as a result of interference. So interference minima. You want reflection, no reflection. What is your objective? Reflection. You don't want any reflection. No reflection should be there. This is your objective. So what should happen here? It means you are saying that in the reflected light, intensity should be 0. And when you are going to have intensity 0, so basically destructive interference should take place in between R1 and R2. ठीक है? Destructive interference should take place in between R1 and R2. So what is the condition for destructive interference? What is the condition for destructive interference? For destructive interference, you know that this delta should be lambda by 2, 3 lambda by 2. This should be 5 lambda by 2. It should be like this. And what is this delta? This is 2 mu ft. And that will be lambda by 2. It may be 3 lambda by 2. It may be 5 lambda by 2. Like this. What you want? You want minimum thickness of the film. What do you want? Minimum thickness. For minimum thickness of the film. For minimum thickness of the film. For minimum thickness of the film. ठीक है, this 2 mu ft, this should be lambda by 2. ठीक है ना? So here I should write it as T minimum. This should be T minimum. So when it is going to be minimum here, you should choose minimum value on the right hand side. So this will be lambda by 2. So this T minimum for anti-reflection films or non-reflecting films, this will be lambda upon 4 mu f. ठीक है? For anti-reflection films, non-reflecting films, this should be the thickness of the film. ठीक है? This formula you have to remember. If you do further calculations, then you will find out that this mu f ठीक है, म्यू एफ, refractive index of the film should be equal to the geometrical mean of the first medium, that is air, refractive index of the air, and refractive index of the substrate on which you are depositing this film. So for best result, I'm not going into its calculation. That's not a very difficult calculation. But right now, I'm just providing you the formula. For the best result, for the best anti-reflecting films, this mu f refractive index of the film should be geometrical mean of the refractive index of first and third medium, means air and glass. So you have to remember this for non-reflecting films or anti-reflecting films. What you have to remember here in this case, that refractive index should be in the increasing order in the downward direction. Second, here in this case, both the reflections, first reflection as well as second reflection, they are taking place at the denser medium. Both times, first medium is rarer, second is denser. So extra phase of pi is introduced. As a result, this extra phase is cancelled out and part difference becomes 2 mu ft cos r, and they are designed for the normal incidence. So that's why this will be 2 mu ft. Okay, so in this way, you have to remember these formulas related to non-reflecting films. Is it clear, beta?
Yes, sir.
Okay, next is highly reflecting films. Okay, next is highly reflecting films.
The previous slide, please.
Okay, beta.
Thank you, sir.
Welcome, beta. Next is highly reflecting films. Highly reflecting films. Okay, highly reflecting films. So what will happen in case of highly reflecting films? You want that maximum reflection should take place. Here, what is your objective here? Maximum reflection should take place. Maximum reflection you want. So here, for the reflected light, or reflected light intensity should be maximum. So what should happen here? In this case, because you want Imax, so constructive interference will take place. So constructive interference will take place in between the reflected light. So here you are going to have a film like this. This is a film. This is glass. Yeah, this is highly reflecting film. This is thickness is T. Okay. Now light is incident on it again. A part of it will be reflected back. A part of it is, this is R1, but here this mu f, what we choose here, mu f, this is mu g, but this time mu f you are going to choose, it should be greater than mu g. Mu f will be greater than mu g for highly reflecting films. So try to understand this first reflection. Okay, if you look at this first reflection, this is air. So here this is denser, this is rarer, so this is rarer. This is denser. So first reflection is taking place at the denser medium. So extra phase of pi or extra path of lambda by 2 will be there. A part of it will transmit like this, and second reflection will take place on the glass. But here mu g is less than mu f. So here for the second reflection, here this is denser and this is rarer. So second reflection is taking place at the rarer medium like this. So what will happen here? This will be like this. Just this will be, you are going to get this second reflected light wavefront after the second reflection, but the second reflection is taking place at the rarer medium. So here no extra phase will be there. So what will be the part difference between R1 and R2? Part difference R1 and R2, between R1 and R2, this will be 2 times mu f t. ठीक है? It is also designed for normal incidence. ठीक है? Designed for normal incidence. It is also designed for normal incidence. Normal incidence. ठीक है? So this will be 2 mu f t. ठीक है? And for destructive and minus lambda by 2. So this will be just minus lambda by 2. This is the part difference. Now what you want that here maximum intensity, reflected light intensity, it should be maximum. So what you should have, constructive interference. This is your objective. For constructive interference, this delta should be 0. It may be lambda, 2 lambda, like this now. So this will be 2 mu f t, 2 mu f t minus lambda by 2. It should be 0. It may be lambda. It may be 2 lambda like this. For minimum thickness, for minimum thickness, on the right hand side, you are going to choose the lowest value. Lowest value is 0. ठीक है? For minimum thickness, I'm going to choose this one. So this will be 2 mu f t minus lambda by 2, and that will be 0. So what will be T minimum here? This is T minimum. ठीक है? T minimum here, it will be lambda upon 4 times mu f. Formula is same for both. But remember this, there is a basic difference that here, this condition is present, that mu f, refractive index of the film, is greater than refractive index of the glass. ठीक है? Here, this is the condition. In case of anti-reflection film, this mu f was less than mu g. So that's the basic difference. Otherwise, thickness formula will be same here. Here, thickness formula will be same. Now, what should be the mu f? ठीक है? What should be the mu f? So for this, rule is that mu g and mu f, they should be very close as possible, as much as possible. So you can write here, for best possible result, mu f and mu g should be close to each other. For best possible result, mu f and mu g should be close to each other. Mu f and mu g should be close to each other. Should be close to each other. Okay? So this is everything about this thin film interference which they can ask in your exam. Next, this is question number 1 related to thin film. A thin film of water having refractive index n equal to 1.333 floats on the surface of silicon oil, whose refractive index is 1.4. So here this is silicon oil. ठीक है, this is silicon oil. Silicon oil. ठीक है. Over it there is a film. There is a water film here. What is this? This is water film. Is over here. Refractive index, they are providing us that this is 1.333. And for silicon, you can write S. Here you can write W. For NS, 1.4 is given here. Here. The arrangement is illuminated by 600 nanometers. So what is lambda? Lambda is 600 nanometer. Light incident normally from the top and large region of the film appears bright red. So what they are saying that most of the region here is appearing bright red. What is the minimum possible thickness of the film? So you have to find out the minimum possible thickness of the films. Try to understand this wavelength is corresponding to or very close to the red color wavelength. ठीक है ना? Light of the red color. This wavelength is very close. And what they are saying that in the reflected light, they are observing red color, bright red color. It means they are saying that whatever light is incident, this is normal incidence, but I am showing you by an angle. So this is reflected light here. Try to understand. First reflection is taking place at denser. So it is having an extra phase of pi. So this is R1. Second will move like this, and second reflection, this is also taking place at the denser. So this is also taking place at the denser. So automatically in both R1 and R2, here remember this, in both R1 and R2, extra phase of pi will be there. So what will be the part difference between R1 and R2? Delta, that will be 2 mu, and film is made up of water, so I'm writing W, or I can write it as NW. You can write it as NW. NW. T is the thickness. For normal incidence, cos R is 1. ठीक है ना? They are saying normally. So cos R is 1. ठीक है? And it will be, what you are getting here, you are observing bright red, means here maxima, intensity maxima or constructive interference is taking place. So what they are providing us, they are providing bright red. So constructive interference is taking place. Constructive interference is taking place. So here it should be कितना होना चाहिए for constructive interference? It, ठीक है ना? So for minimum thickness, you cannot take it 0. ठीक है? You cannot choose it 0. So it should be n lambda, or you can choose it as lambda. So for minimum thickness, ठीक है? It may be 0 lambda, 2 lambda, 3 lambda, like this, but you have to understand if 0 will be there, thickness will be 0. That doesn't have any meaning. So it will be lambda, 2 lambda, 3 lambda, like this. So what will be T minimum? T minimum in this case, that will be lambda upon 2 times NW. This is 600 nanometer divided by 2 into, this is water, film is of water, so this will be 1.333 nanometer. T minimum is this. So this will be how much? Please calculate it. This will be 225. 225 nanometer. So T minimum should be equal to 225 nanometer. This should be the answer of this question. So you have to take care of, you should be very careful. You should take utmost care that where reflection is taking place, where first reflection is taking place, where second reflection is taking place, either phase difference is introduced only in one one reflected wave or or extra phase is also introduced in second reflected wave or not? You should be very careful about this. So this will be the answer of this question. Is it clear?
Yes, sir.
Next question. Go through this question and try to solve it.
So could you please show the reflecting film?
Okay, beta. This one or first? Hello?
So the highly reflective film.
Okay. This is highly reflecting films.
Thank you, sir.
Welcome, beta. Now, go through this question. A thin film of alcohol is spread over a surface when light from a, because they are talking about surface, we can assume it is a denser medium. When light from a tunable source is incident normally, the intensity of the reflected light at the detector is maximum for lambda equal to 640 nanometer and minimum for lambda equal to 512 nanometer. Taking the refractive index of the alcohol to be 1.36, both the given wavelengths, the minimum thickness of the film would be. So what will be the minimum thickness of the film you have to find out? This is a very good question. So here, film is made up of alcohol here. So here, this is alcohol, you can say. Alcohol. Here, this will be some substrate. I'm saying this is glass substrate. Okay, this is glass. And here, mu g, this is mu g. And mu g is greater than this mu film. I'm saying this is mu f. And mu f, what is the refractive index of alcohol? That is 1.36. So film is having a refractive index of 1.36, and this mu g is greater than mu f. It is not given here, but it is understood. Okay, this will be. Now you have to find out the minimum thickness, and you have to find out thickness such that for 640 nanometer you are getting maxima in the reflected light, and for 512 nanometer you are getting minima. You are getting minima. So light will be incident like this. A part of it will be reflected back. This is R1. R1. First reflection. Try to understand this first reflection is taking place at the denser medium. So extra phase of pi will be there. A part of it will transmit into the film, and again a reflection will take place from here, and then it will come out like this. R2. Here second reflection is taking place here. Here mu g is greater than mu al. So this is also at the denser. So in between R1 and R2, you are having an extra phase of pi. So this is going to cancel out this extra path lambda by 2, it will cancel out. So what will be the part difference here? That will be delta, you can say. That will be delta, and delta will be this delta. This will be 2 mu ft. Mu ft. For maxima, ठीक है ना? For maxima, this 2 mu ft, it will be n lambda. It will be n lambda. ठीक है? And what it will be for minima? For minimum intensity, for minima, it will be something like this 2 mu ft, and this will be 2m plus 1 lambda by 2. It will be like this. ठीक है ना? It is going to be like this, and this will be lambda 1. Here lambda 1 is 640, and this will be lambda 2. So that is lambda 1. You can say this is lambda 1, this is lambda 2. Divide these two. So left hand side they are equal. So you can write this n lambda 1. This will be, take this 2 inside. So this will be m plus 1 by 2 into lambda 2. Lambda 2. Okay, it will be like this. Is it clear up to this point, beta? Or
Yes, sir.
even if you want, you can also write like this. It doesn't matter. Okay, so this lambda 1 by lambda 2, or you can say this lambda 2, lambda 1 by lambda 2. This is lambda 1 divided by lambda 2. So this will be 2m plus 1. 2m plus 1 divided by 2 will be here. So I'm writing it as 2n. It is like this. So this will be the equation. Now lambda 1 and lambda 2 are given. Lambda 1 is 640. And this will be 512. ठीक है, 512. This will be. Is it clear here up to this point? So
Sir,
simplify it. Yes, beta.
how to write path difference, sir?
Part difference in the last class I have derived that part difference will be 2 mu t cos r.
Okay, sir.
ठीक है. So
Yes, sir.
for normal incidence, this angle of incidence will be 0. Angle of refraction will also be 0. So cos 0 will be 1. So that will be 2 mu t. Now different cases may be there. If only in R1 extra phase is there, and in R2 this extra phase is 0, then part difference as I have derived it will be 2 mu t minus lambda by 2. But here in this type of cases where both the reflections are taking place at the denser medium, this extra phase is introduced in both R1 and R2. So they are going to cancel out because you want to find out the phase difference or part difference. So this will cancel out this one. Okay, so this will be simply 2 mu ft here in this case. So now solve it. Okay, how simplify it? Beta bataiye how much it will be. On simplifying, what you are going to get? This will be 5 by 4. ठीक है ना? You are saying 1.25. So this will be 5 by 4 beta. So what you are writing here, 2m plus 1 upon 2n. 2m plus 1 upon 2n. And that is 5 by 4. What will be the minimum value of m and n? So you can write this 5 as 2 into 2 plus 1 divided by 2 into 2. So here minimum value of n will be 2 as well as m will be 2. ठीक है? So minimum value of n and m corresponding to the given conditions will be 2. ठीक ना? They will be 2. So if you now substitute these values of n and m here, you can choose this 2 mu ft equal to n lambda 1. ठीक है? 2 mu ft equal to n is 2, and this will be lambda 1. What do you want to find out? You want to find out t. So this will be 2 lambda 1 upon 2t. So 2 is going to cancel out. And what is lambda 1? Lambda 1 is 640. ठीक है? Lambda 1 is 640 upon 1.36. 640. And here this will be beta mu. This will be 2 times mu f. And how much is this? What is the refractive index? 1.36. Substitute here. 1.36. Find out this thickness. And this will be in nanometer. ठीक है, calculate this. What will be this value? This will be,
सर
yes बेटा please.
सर n और m की वैल्यू 2 क्यों हुआ?
Okay, look here, you are having this equation. You want to find out the minimum value of m and n, so that thickness should be minimum. There is no upper limit, but we always are going to find out the minimum value. If you are given this equation 2m plus 1 upon 2n equal to 5 by 4, if I give you only this equation and I will ask you what is the minimum integer values of m and n which are going to satisfy this. So for this simplest
यस
method
सर,
is try
समझ
to
गया।
convert this ratio in this form. ठीक है,
हम्म
so I have from here by writing in this simple manner, I find out n will be
हम्म
2, m will be 2 for minimum value of thickness. Maybe higher values you may find out. ठीक है, higher values you
but
may find out
they will
which,
not satisfy this condition.
yes better. So this
Yes
will
sir.
be, find out this ratio 640 upon 1.36. It will be roughly 470. You can check 470.58.
Yes,
Four
sir.
se-
It is fine.
470.58 nanometer. This will be the answer of this question. ठीक है ना? Next question बेटा. That's a next question. It
Sir,
is a very, yes बेटा please.
the slide of the first question, please.
Okay बेटा. This one or question number 1?
First question, one.
This is the first one. Is it okay?
सर
Yes.
आप जब वो पढ़ा रहे थे ना नॉन रिफ्लेक्टिंग फिल्म्स एंड इसके बारे में, तो वहां से तो टी मिनिमम मतलब दोनों केस में लैम्डा बाई 4 म्यू एफ आया था ना, तो यहाँ 2 क्यों हो गया वो?
Here
थोड़ा
condition is different ना बेटा. Here try to understand. ठीक है ना? Here this is what was in case of anti-reflection films. ठीक है, what was anti-reflection film? In case of anti-reflection film, where this refractive index was increasing, you was looking here destructive interference. So that was lambda by 2. That was lambda by 2. So here you was writing 2 NWT equal to lambda by 2. But here what they are saying that in the reflected light, you are getting bright red. Bright red means you are getting a maxima. So you have to apply the condition of maxima here.
ओके
In
सर.
in case of non-reflecting film, that was minima or destructive interference. But here it is constructive interference, so condition is different.
ओके
Is
सर.
it clear?
यस.
Now, next one. Next question. Question number 3. A beam of plane. This is a very simple question. You are all aware of it, but because this question was asked in the exam, I am discussing it. A beam of plane microwaves of wavelength 12 centimeter strike the surface of a dielectric at 45 degree here. ठीक है, here this is air and here this is dielectric. This is dielectric and it is incident here. Light is incident at an angle of 45 degree like this. ठीक है, 45 degree. 45. If the refractive index of dielectric here, its refractive index is 4 by 3. Here refractive index of air is 1. What will be the wavelength of the microwave in the dielectric? Here, if wavelength is lambda, what will be the wavelength here in the dielectric? That will be lambda upon mu. ठीक है? wavelength will be reduced by mu. So this will be lambda. Lambda is 12 centimeter, and this will be 4 by 3. So this will be 9 centimeter. ठीक है ना? This should be 9 centimeter. So this should be the wavelength of the microwave in the dielectric. So when some light is traveling in the air and then light enters into a medium, then refractive index changes, and refractive index becomes, refractive index changes. As a result of refractive index, its speed is going to change, wavelength is going to change. Only frequency remains same. Only frequency remains same. So it will be like this. Okay? So this will be, you can say in the air, C is equal to nu into lambda. So if I divide this C by this mu, this will become C by mu here. And on this side, I can write lambda upon mu. And this will be the velocity of the light in the medium. So this will be V. This will be nu, and this will be nu wavelength. You can say lambda prime. So lambda prime in the in this medium will be lambda upon mu. Velocity in the medium will be c by mu. So in this way, in this simple manner, you can remember it. So this was a question that was asked in the exam. Next question, beta. Please go through this question. Next question. Question number 4. A flat soft film has a uniform thickness of 510 nanometer. White light having wavelength in the range about 390 to 700 nanometer is incident normally on the film. If the refractive index of the soap is 1.33, refractive index of the soap is this, what will be the dominant color of the reflected light? You have to find out. Okay, so in the reflected light, okay, in the reflected light, constructive interference should take place. So you are observing, you are saying that we want to observe the dominant color in the reflected light. Dominant color means constructive interference should take place for that dominant color light. So here we are interested in constructive interference in reflected light. Now, can you tell me what will be the situation of the film here? This will be the soap film. Okay, this will be the soap. This will be air. And this will be air. This will be air. So try to understand a soap bubble. In case of soap bubble, it will be like this. Inside it, this will be air. Here you are having air. And this is soap layer. And in between, you are going to have a soap layer. Okay? So air, soap, and air. This type of sequence will be there. So in this case, if you look at reflections, first reflection, because soap is having 1.33, this refractive index is higher than the refractive index of the air. So first reflection here you can observe. First reflection will take place at the denser medium. This is the first one. This is R1. R1 is taking place at the denser medium. So first reflection is taking place at the denser medium. A part of it will transmit here. Second reflection will take place at the air. So it is taking place at the rarer medium. So this second is taking place here. This is rarer medium. This was denser. Here in this case, this was rarer. This was denser. So what will be the part difference here? This will be R2. So extra phase or path length is traveled by R1 only, not R2. So this will be 2 mu f. For normal incidence, cos R is 1. And this will be minus lambda by 2. minus lambda by 2. And what you want constructive interference. ठीक है, what do you want? You want constructive interference. ठीक है, तो क्या चाहिए हमें? We want constructive interference. So for constructive, what you want here? You want here constructive interference. Constructive interference for maximum intensity, for bright fringes. For bright color, dominant color, you need constructive interference. So for constructive interference, it should be like this. This may be 0. ठीक है, it may be 0 हो सकता है, it may be lambda, it may be 2 lambda. You should remember this. So I can write it as n lambda. N will be, here you can choose 0 because this lambda by 2 is here. ठीक है, if you choose 0, lambda by 2 will be on this side. So I can write it as n lambda. So 2 mu f t, this will be 2n plus 1 lambda by 2. Lambda by 2. ठीक है, this will be, now from here I can find out lambda. So lambda, this will be 4 times mu ft. 4 times mu ft upon 2n plus 1. This will be. So what will be the lambda? What will be the wavelengths which are going to form the constructive interference in the reflected light? That will be this. So lambda will be 4 times mu ft. 4 times mu ft upon 2n plus 1. So here 4 times mu ft upon 2n plus 1. Substitute these values. ठीक है ना, substitute these values. What is the value of mu f? 1.33. So this will be 1.33. And what is the thickness? ठीक है, thickness कितना है बेटा? Thickness is 510 nanometer here. So right here 510 nanometer. 510 nanometer and divided by 2n plus 1. And this will be nanometer. Calculate this number, upper number, this will be, calculate it, this will be 2713 upon 2n plus 1. This is nanometer. So these are lambda. These are the possible lambdas for which constructive interference will take place. Now, in which range? This lambda will be 390 to 700 nanometer. So 390 nanometer to 700 nanometer. In this range, you have to find out the wavelength which will form constructive interference in the reflected light. So for this, first I will write n equal to 1, n equal to 0, sorry. So this will be lambda 1, you can say. What it will be? This will be 2713 divided by 1. Okay. So this will be 2713 nanometer. This is not my answer because this wavelength is outside this range. Second, I'm going to choose n equal to 1. So this will be lambda 2 and this will be 2713 and divided by 3. So this will be 900 something. This will be something like this. It will be outside this range. So we are not interested in this. Now next will be n equal to 2. So what will be lambda 3? 2713 and this will be 5. So 5 5s are 25. 5 4s are 20. 20 and this will be 13. 5 2s are 10 and this 6 nanometer. This will be this one beta. Is it clear? Now this is my range. This is okay. Next is if you write it n equal to 3, then lambda 4 you are going to get. This will be 3. 3 to just 6 plus 1 7. 2713 divided by 7. This will be 300, 30. No, 3, not 30. Roughly this, and it is lesser than this nanometer. You can look. So we are going to get constructive dominant color wavelength, which is forming constructive interference is this. So this will be my answer. This will be my answer. This wavelength is going to form the constructive interference. Now, which colors they are providing us? Violet, green, red, and white. Violet, green, red, and white. Try to understand. This will be maximum wavelength. Okay, so this will be red. This will be violet. Okay. And for this particular, it will not be white. So which one is left? It cannot be violet, it cannot be red, it cannot be white. So what it will be? This will be green color. So this is going to be green color. So green color wavelength will dominate in the reflected light button. So that is going to reflect. Is it clear to everyone? So this is all about thin film interference. You can solve all the questions related to it. In tomorrow's class, I will discuss Michelson interferometer and all the questions related to that. I'm not going into the working of the Michelson interferometer, but I will explain you the basic aspects of the Michelson, how it works, and how can you solve the questions related to Michelson interferometer. I will give you the formulas and I will discuss questions how you can solve them. So this for today it is over. Yes, beta, please.
मैक्सिमम लाइक फॉर द ब्राइटनेस केस में कंस्ट्रक्टिव इंटरफेरेंस के केस में पाथ डिफरेंस इक्वेट करते हैं ना एन लैम्डा के साथ,
Yes,
वहाँ
beta.
लैम्डा को जीरो कंसिडर नहीं करते ना, लाइक सॉरी एन वैल्यू गोज टू
No, it depends upon what is the part difference you are having. Try to understand. Okay, if your part difference is like this, if your part difference is coming out to be 2 mu ft, okay, or cos r, then try to understand you cannot choose 0. Okay, na? In this case, if part difference is this, you cannot choose 0 because if you are choosing 0, then t will be 0 and there is no problem left. So lambda, 2 lambda. So you cannot choose 0 here because otherwise this t is going to be 0. Thickness will be 0. Okay. Second, if your part, so here it will be lambda, 2 lambda, 3 lambda like this. But if your part difference is 2 mu f t cos r minus lambda by 2, suppose you are having this. In that case, you can have 0. 0, lambda, 2 lambda like this. Because here if you are choosing 0, then this 2 mu ft cos r, it will become lambda by 2. So in this case, there will not be any problem. So here, it depends upon the situation, what is your part difference. So
ओके
whatever problem I have, whatever derivation I have done, in that derivation, this was the situation. So you are using this. But in case of anti-reflection films, you are using this one, so you cannot use 0. Sorry, in case of second one, highly reflecting, that was highly reflecting film. No, in this case, first case, just 1 second. Okay, here, what was the part difference? This was the part difference. So here I was not choosing for normal incidence, this is, and what I was choosing here, try to understand. For destructive interference, I was lambda by 2, lambda 3, lambda by 2. And in the next case, here 2 mu ft minus lambda by 2, here you can choose 0 because this is lambda by 2. It will go on the right side and thickness will not be 0. So in this case, so you have to take care of this aspect.
यस ओके
So it is here. So this is the condition for constructive interference. Constructive interference. So we have to take care what is the path difference. Okay, beta. Thank you
Sir,
very much. I
please
will
show
show you.
all slides, sir.
Yes, beta. Just. This is first slide. Second. Third. Fourth. Fifth. Sixth. Seventh. Eight. 9, 10, 10. Okay. You can also solve this question. I'm showing you. This is simple question you can solve. ठीक है? This is for practice. A parallel beam of light of wavelength lambda is incident normally on a thin polymer film with air on both sides. If film has a refractive index and greater than 1, then second order bright fringe can be observed in the reflected light when thickness of the film is. What is the meaning of second order here?
Sir, we have take two.
2 matlab?
Means when we are calculating
So देखो,
lambda,
a
A
parallel beam
lambda.
of light of wavelength lambda is incident normally on a thin polymer film with air on both sides. So here you are having polymer on both sides. ठीक है? So what will be the part difference in this case? In this case, if you look at part difference, that will be R1 is here, R2 is here, this will be pi, and here this is polymer. Here this is air, this is air. So part difference will be 2 mu f t. ठीक है, cos normally incident, so cos r. So 2 mu t, this will be minus lambda by 2. This will be the part difference. For the second order, what is the meaning of second order here? Bolo. What will be the meaning of second order here? So for constructive interference, what you want? You want bright fringes here. So what will be the part difference for constructive interference? Constructive. So don't confuse with order n equal to 2, 3, 4, 5, 1, 2. Don't care about this. So here it will be 0. ठीक है? This will be lambda and this will be 2 lambda. So if you are choosing this one, this is 0th. ठीक है ना? This is 0. So part difference here is 0. So this will be 0th, this will be first order, this will be second order. So this will be how much? This will be 2 mu ft. Uh, yes, 2 mu ft. This will be 2 lambda. It should, this should be, sorry. Here, try to understand one thing here. If you are having Young's double slit experiment, you're calling it a 0 because both the waves, they were traveling exactly equal paths. ठीक है, exactly equal paths. But here they are not traveling exactly equal paths. ठीक है ना, they are not traveling exactly equal paths. So you can say this will be the first one. ठीक है ना, this will be the second one, this will be the third one. ठीक है, not 0th ones. Here counting will be corresponding to this first. That's why I was saying it's not 1, 2, 3. Second, and this will be third, not 0th. For 0th, they should travel exactly equal paths. ठीक है, here path difference is becoming 0, but not due to the path traveled, that is due to the reflection here. So they are not traveling R1 and R2, they are not traveling exactly equal paths, but here because due to reflection, extra phase of pi is there. That's why. So this is called, this will be the first one, this will be the second, this will be the third. So here it will be lambda. This will be on this side. It will be lambda by 2. And this will be plus lambda. So this will be 2 mu ft. This will be 3 lambda by 2. So thickness T, this will be 3 lambda upon 4 mu f. 4 mu f. Okay, this will be. So this will be in this way. If you are having, suppose you are having some another question where situation is like this, 2 mu ft. Try to understand. Here you cannot choose 0, so this will be lambda, 2 lambda, 3 lambda. So this will be the first again. This will be second order. So 0th order is not here. This will be third. Okay? So in this case, if they ask you second order, this will be mu f t 2 times, that will be 2 lambda. So here t will be simply lambda upon mu f for the second order. Okay? For second order here. So remember this aspect. So your answer here in this case will be this 3 lambda upon 4 mu f or 4 n. This will be your answer. So actually 0th order maxima, that at that was said because 0th order, because two light wavefronts which were emerging from slit S1 and S2, they were traveling in air, then they were traveling exactly equal paths. Okay? And due to that reason, that aspect was there. So here, this will be first, this will be second, this will be the third here. This will be the third. So remember this. This question was asked in the exam.
So the last slide, please.
Okay. So it depends upon, everything is depending whatever is the path. So you should be very careful what will be the path difference every time. ठीक है, चलिए बेटा, this is the last one. Thank you very much.
Thank you, sir.
Welcome बेटा.
Thank you, sir.
Welcome.